Hello, this is Mrs. Rodolfi, and I am going to be going over lesson 17.1, the graphing method in the SpringBoard Algebra 1 textbook. I am currently on page 254, and I'm going to go over letter C right now. So in this lesson, the graphing method is being used to solve systems of equations. So when we're given two linear equations using the same variables, we can find the solution by graphing them. And the solution is the intersection point. So it's the ordered pair that makes both the equations true. So I am going to review graphing a couple of these on this page, 254. So I like to color code them and use different colors for each function just to be able to differentiate. So I'm going to use this like teal color, greenish color for y equals 3x minus 5. So I always first look, is it in slope-intercept form? Yes, it is in y equals mx plus b. So then I can start graphing by looking at the constant -5. That's your b value, which is at 0, -5. So I'm going to go on my y-axis, 0, -5, and put a point. Then I want to look at my slope. The slope is your m value, m equals 3, and then I always make it into a fraction over 1. This is your rise over run. So then I know I'm going to go up 3, right 1 from my starting point. So 1, 2, 3, right 1, put a point. 1, 2, 3, right 1. 1, 2, 3, right 1, 2, 3. Just keep going until you run out of graph space, then go the opposite direction. 1, 2, 3, down, left 1. Always use a ruler to draw a straight line connecting your points. If for some reason your points don't form a straight line, that means you did something wrong when you were graphing it, when you were calculating the slope. So always make sure it forms that straight line. These are all linear functions. All right, then we would need to graph our second linear equation, y equals -2x plus 4. So I always look at that last number, the constant. 0, 4 is our y-intercept, so put a point there. Your slope is your m value, -2 over 1. So if it's -2, I'm going to go down 2 and then write 1. Your run, your denominator is always positive, so that will always, you'll either go up or down, but you'll always go right, depending on whatever your denominator is. So down 2, right 1, down 2, right 1. Opposite direction, up 2, left 1, up 2, left 1. Connect your points. Then to find the solution, we have to find the ordered pair where they intersect. So where both these lines meet, which is going to be right here. Now on this graph, it's really hard to tell. This is not an exact point. It's not a whole number. It's going to be a decimal. So I'm going to create another video that I will also post on today's lesson of how to use Desmos to also graph. Because sometimes we cannot see the exact answer, and we need to use a calculator to do that. Also, you can use Desmos graphing calculator on sessions 2 and 3 of the LEAP test, and it can do so much for you that where you wouldn't even have to graph this by hand when you were taking the LEAP test. You could just type it into the computer and figure out the answer right away. So I also want to show you that to start exposing you to Desmos, since you can use it on your final exam. So you will go to the Desmos and type it in, but I'm just going to give you the solution right now until you can get to that video. So it's 1.4 and 0.4. Or hold on, I think I just wrote that one. I think it's 1.8. Let me go to my key. 1.8, sorry. 1.8 and then 0.4. All right, then you always want to check your work by going back to the original equations and substituting 1.8 and 0.4. So this is our solution. X equals 1.8, y equals 0.4. Remember, it's always x then y in an ordered pair. So looking at this first equation, so let me go back to my colors. Y equals 3x minus 5. So I'm going to substitute 0.4 for y equals 3 times 1.8, which is our x value, minus 5. Then you just solve it. So 0.4 equals 3 times 1.8 is 5.4, and 5.4 minus 5 is 0.4. So if it's a true statement, it equals the same number on each side, then that means that that ordered pair is a solution to that equation. Then we need to make sure that it's also a solution to the second equation for them to be a solution of each other, a system. So then I would substitute 0.4 equals negative 2. So this is y equals negative 2x plus 4. So negative 2 times 1.8 plus 4. Negative 2 times 1.8. Let me do that on my calculator. Is negative 3.6 plus 4 gives us 0.4. So 0.4 equals 0.4. It is also a solution. So anytime it says check your work, or even if it doesn't, you always want to go back and check by using algebra to substitute that ordered pair back into the equations. All right, let's do one more example. Now this one, again, I first looked to see if it's in slope-intercept form. I noticed that these are in standard form, ax plus by equals c. I want to rearrange these equations so that they are in slope-intercept form. So starting with, I'm going to do it over in the notes section here. 3x plus y equals 1. So if we want to convert it to y equals mx plus b, we want y isolated on the left side of the equal sign, then we want our mx, our x term, after the equal sign, and then our constant at the end. So I see my constant of 1 is already on the right side. I need to leave that. 3x, that's my x term, which is on the left side of the equal sign. So I need to do the inverse and subtract 3x from both sides. Then I get y equals. I cannot combine like terms. 1 minus 3x, those are not like terms, so I have to keep them separate. Going back to my formula, my x term is the next thing I would write. So negative 3x is my x term, and then plus 1. Now I can graph it. 1 is my y-intercept. So 0, 1. So I'm going to graph that. Then my slope, m equals negative 3 over 1. So from my y-intercept, I go down 3, right 1. Down 3, right 1. When I go the opposite direction, I go up 3, left 1. Up 3, left 1. Then I use my ruler to connect my points. All right, then the next equation is 6x plus 2y equals 10. Again, I want to convert this to slope-intercept form, so I see my 6x, my x term, I need to move to the other side by doing minus 6x. And I get 2y equals negative 6x plus 10. I need to isolate y, so if it's 2 times y, the opposite is divide everything by 2. Y equals, so negative 6 divided by 2 is negative 3x, and then 10 divided by 2 plus 5. Now I can graph this equation. My y-intercept is 0, 5, shown by my last number, the constant, so I'm going to go up to 0, 5. My slope is negative 3 over 1, so from the y-intercept I go down 3 over 1, down 3, right 1, Opposite direction, up 3, left 1. Connect your points. Now going back to what we have talked about in previous lessons, notice that our slope was the exact same for both of these, -3 and -3. As we've discussed in looking at the look of these lines, these are parallel lines. They have the same slope. Now a solution to a system of equations is when they intersect. So will these parallel lines ever intersect? No. So for this type of system, there is no solution. They will never intersect. I hope this video was helpful. Make sure you finish writing the notes to this lesson, answer these questions at the bottom that relate back to what we just did, and check the key for all the other answers, and let me know if you have any questions. Have a great rest of your day. Bye.